Build better search with metadata filters and weighted scores. By the end, you will have a clear hybrid search pattern. You will see how to filter by metadata, combine token overlap with vector similarity, and add a recency boost to favor fresh content. You will also learn which parameters to tune and why they matter. I'm Professor Pi, teaching search and IR from basics to advanced in simple Python. Hybrid search solves a very practical problem. Pure keyword match finds exact words but misses meaning. Dense vector search finds meaning but can ignore important properties like category or date. Mixed search gives you both. The usual downside is complexity. You need to pick weights and build a filter step. That cost pays off when you want higher quality top results for real users, not just raw similarity scores. Think about it this way. A user types a question, and we only want answers from the billing section and from the last year. First, we narrow the candidates by metadata. Then we score the remainder by lexical overlap and by a semantic vector. We mix those scores with a weight so that exact matches still matter, but semantic matches can rescue rephrased queries. Strengths are relevance and control. Weaknesses are tuning and slightly higher compute. We'll build a small pipeline that demonstrates each step on the same corpus. You will see a simple token overlap rank, then add metadata filtering. Then mix in a normalized vector score. Add a recency boost, and finally, return the top 5 hit. Now let's start with the basic lexical scorer. This snippet scores documents by raw token overlap and ranks them. This snippet builds a simple baseline. It tokenizes the query and each document and counts shared tokens. Those overlap counts become the document score, and documents are sorted high to low. This gives an immediate picture of what exact word retrieval looks like. If you increase the minimum overlap threshold, you will reduce false positives, but might lose rephrased matches. If you lower it, you will get more candidates, but more noise. This baseline is fast and transparent, and it sets expectations for how much semantics must add. Next, we will limit candidates by metadata before scoring. This snippet adds a metadata filter before scoring token matches. This example shows the filter step. It reduces the document pool using metadata like category, author, or language. Only filtered items move on to token overlap scoring. That control is what stops semantically similar but contextually wrong hits from surfacing. If you tighten the filter, you reduce latency and improve precision, but you risk dropping valid but mislabeled items. If you relax it, you preserve recall at the cost of speed. Filters are especially useful when your index mixes multiple domains, like blog posts and support articles. Now we'll combine lexical counts with a vector similarity. This snippet mixes lexical counts and a normalized vector score. This code merges two signals. It computes a normalized vector similarity that measures semantic closeness and then blends it with the lexical overlap count using a weight parameter. Normalization keeps the two signals comparable. The weight controls influence, pushing it toward lexical favors exact wording. Pushing it toward vector favors meaning. Tuning that weight is the core trade-off. For many queries, a middle value yields the best top 5 accuracy. Also note that normalization and scaling affect how sensitive the mix is to outliers. Next, we add a simple recency bias to prefer newer documents. This snippet applies a simple recency boost to favor newer content. This snippet demonstrates a time-based modifier. It computes a recency factor from each document date and multiplies the hybrid score by that factor. A common pattern is an exponential decay where newer items get a boost and older items slowly lose weight. The decay speed is an adjustable parameter. Faster decay strongly favors recent items, but can ignore valuable evergreen content. Slower decay balances freshness with longevity. Recency is crucial for news, change logs, and policy documents where time matters. Finally, we'll finish the pipeline and pick the best result. This snippet finishes a filtered hybrid search and returns the top hit. This example ties everything together. It applies the metadata filter, computes lexical and vector scores, applies normalization, blends scores with your chosen weight, adds the recency multiplier, and then sorts to return the top 5 documents. The final output is easy to inspect. If you want faster results at scale, run the filter and lexical pass first to reduce candidates. Then compute vectors only for the shortlist. If you want more precision, raise the lexical weight or tighten the filter. If you want more semantic breadth, raise the vector weight. Recap: hybrid search combines a metadata filter with a weighted mix of lexical and semantic scores and an optional recency boost. Use it when you need precise, context-aware top results across mixed content types. One caveat is that you must tune weights and filters for your collection and query patterns. Next step, tune the weight between lexical and vector scores while evaluating top 5 accuracy on a held-out query set. That single experiment will show how your pipeline balances precision and recall. If practical IR that actually helps users matters to you, subscribe and watch the rest of the IR videos.